Hello everyone. In this lecture, we are going to see about the types of transmission line protection. So, for seeing about transmission line protection, first we need to define or know what is a feeder. Right? Feeder is a connecting link between two circuits. Right? That two circuits may be consisting of transmission lines, which are short transmission lines, medium transmission lines, as well as long transmission lines, or that may be distribution lines also. Right? So generally transmission lines may be interchanged, the word may be interchanged with the feeder, or feeder in sometimes can be called as transmission line. So generally in a power system, the protection is mainly required for transmission lines, as transmission lines are laid over long distances and exposed to different factors of atmosphere like rain, heavy rain, winds and all. So the probability of faults in the transmission lines is more. So generally, protection is mainly required for transmission lines. So generally, if transmission line protection is meant or feeder protection is meant, that means it means transmission line protection only, right? Then let us see what are the basic requirements of transmission line protection. So the main requirements of protection of transmission lines are: if any short circuit is occurring, the circuit breaker which is nearest to the fault should immediately open, right? Should immediately work. Relay should work, or the circuit breaker should open. That means it is called as primary protection, right? So whichever acts first, whichever activates first in case of fault, that is called primary protection. So let me show you by an example. So let us take a power supply system. So these are the feeders. There may be parallel feeders also, right? So if a fault occurs on the power system at any place, right? Let me take a fault here. So the circuit breaker which is nearest to the fault must open first, right? So in case of this one here, B is the circuit breaker which must open first, right? So that is essential, right? If in case this circuit breaker which is nearest to the fault is failing, then we need a backup protection, right, which activates in case of failure of the primary protection, right? So another main requirement of transmission line protection is we require the protective system such that it operates in a minimum time, right? So the relay which is nearest to that should take minimum time to operate so that the power system stability is not affected, right? So these are the three main requirements of transmission line protection. Now let us go to different types of protection schemes, right? Of that, first one is non-unit type. So non-unit, by meaning unit, you know that in case of protection of transformers, protection of alternators, all those are unit type protection because the protection is taken in a particular zone, right? So if I need to protect this part of the power system, that is called a unit protection or zonal protection, right? So two different schemes of protection in transmission line protection is non-unit type, which is again done in two methods, that is time or current graded overcurrent protection and distance protection, right? These are the two different schemes for non-unit type protection. As well as coming to unit type protection, here also there are two schemes, that is pilot wire differential protection and carrier current protection. So let us see all of these schemes in detail in the coming lectures, right? Now let us see on what factors this selection of type of protection scheme is done. So the selection of particular scheme of protection depends upon the following factors. Those are, first one is economic viability or economic justification of scheme to ensure there is continuity of the supply by using that particular protection scheme. So next one is type of feeders. Which type of feeders? Depending upon that, we need to choose different types of protection scheme. There are two different types of feeders, that is radial and ring mains. So about this we are going to see in detail in the coming lectures. So the next factor that affects the selection of scheme of protection is availability of pilot wires, right? As we have seen in the protection of alternators or protection of transformers, in differential protection scheme we need pilot wires, right? So for how long you are using this differential protection, for how much long you need to take the pilot wires. So is it economically beneficial when compared to the protection scheme, when compared to the unit that is needed to be protected. So that depends upon this factor, that is availability of pilot wires. And the next one is number of switching stations in series between supply end and far end of the system. So how many switching stations are there between the starting and ending of the system? That thing also depends upon the scheme of protection. So last one is system earthing. That means whether the neutral is grounded or insulated. This also affects the selection of particular scheme. Now let us see on what factors, so which of these factors are applicable for what type of scheme of protection. So now coming to time or current graded overcurrent protection. So it is generally employed for as backup protection for long transmission lines, right? For long transmission lines it is employed, or where a time lag is required. What is time lag? Time or overcurrent graded or current graded. By the meaning itself you can understand that there is a involvement of time, right? That means whenever a time lag is permitted in a system for react when a fault is occurred, then in such systems time or current graded overcurrent protection will be used, right? In cases such that instantaneous operation is not required, that means it is okay if the relay operates after some time delay, like IDMT relay we have seen in relays, right? So in such cases this type of protection is taken. So it's mainly used in distribution feeders in coordination with fuses, right? Fuses works whenever the fault is occurred, as well as a backup protection there. This type of time or current graded overcurrent protection is also used. So they are also employed for ground faults also. Alright, ground faults also. We know that overcurrent protection, there are some disadvantages of overcurrent protection as we have seen in the relays, right? What are the disadvantages there? We have seen that overcurrent relays are affected by type of faults and also source impedance also. So because of the disadvantages, we go for distance protection, which is a high speed protection and is not dependent upon, not affected by the type of fault. So generally the current trend which is used in power system is to use static distance relays. Nowadays static distance relays are used for all types of line faults. Static distance protection is used. So for all type of faults, that is, it may be face to face or face to ground faults as main and backup protection also for short, medium as well as long transmission lines. So whereas as we have seen, let us revise. So reactance relay is used for short transmission lines, and impedance relay is used for medium transmission lines, and Moore relay is used for long transmission lines. So why we are going for this one is already explained in the distance relays topic, right? Next, pilot wire differential protection. It is a unit type protection, so which would operate only for faults occurring in the particular area or the protected zone, right? So it is meaning of unit type. So it is used for short transmission lines where cost of the pilot wires is not very high. So depending upon the area which is to be protected, depending upon that how much pilot wire we need to take for differential protection. So is it beneficial when comparing to the cost of unit which we are protecting? So if the unit cost is much greater than the pilot wire cost which is to be employed, then only we go for pilot wire differential protection. So it is beneficial only for short transmission line where the length of pilot wires that is to be taken is very small, right? So next, carrier current protection. Coming to carrier current protection, so it is used for long lines and interconnected lines to simultaneously open circuit breakers on both sides. So when a fault occurs, when on both sides, circuit breakers on both sides, if we need to open, then this type of carrier current protection is used, right? So Generally 220 kV and above. So greater than or equal to 220 kV lines are equipped with carrier pilot or high speed distance relays. Okay, and 33 kV lines are provided with directional time lag over current relays or high speed distance relays. In the same way, 11 kV radial feeders are usually provided with time lag over current relays supplemented by instantaneous relays. Sometimes only HRC fuses are used due to economic considerations also in 11 kV lines. So maybe HRC fuses also used due to economic consideration, or overcurrent relays also may be used. So apart from these all concepts, there is one more important point, so which is to be taken care while selecting the type of protection scheme, that is auto reclosure. So what is this auto reclosure? Generally, when small faults occur in a power system, they have the capacity to recover by itself. The fault may be cleared by itself. So that is auto reclosure. So most faults on EHV lines, extra high voltage lines, are caused due to lightning, right? Generally due to lightning, these are very much affected. This leads to flashover across insulators and exists for short duration only. So therefore, instantaneous reclosure is happening within EHV lines in generally 12 cycles. So it takes 12 cycles to close itself, right? Therefore, it takes 12 cycles to complete. So generally more than one reclosure is not allowed. So whenever a fault happens, the circuit breaker may be open and closed by itself for small faults. So if during one reclosure the fault gets cleared, then it's okay. But if more than one reclosure it takes, it affects the stability of the system, because continuous there is an imbalance in the currents due to circuit breaker opening and closing concepts. So more than one reclosure is not allowed generally for the protective system. So but it needs 12 cycles for the reclosure of EHV lines, so which affects the stability point of view, right? So on lines up to 33 kV, most faults are caused due to external objects such as tree branches and all. So this is due to less height of poles compared to the adjacent trees. So the general 33 kV lines are shorter than the trees. So this affects the stability of the 33 kV system, so which causes many faults. So the external objects which may not clear the fault reclosure, may not clear the fault or cause reclosure and may require additional reclosures. So in one reclosure it may not complete, but it needs additional reclosure to complete. It is not a continuous fault or permanent fault. It is a temporary fault but needs more reclosures, right? So usually 3 reclosures which goes for nearly 15 to 120 seconds are allowed, right? So protective system is taken such that it goes for 3 reclosures which last for nearly 15 to 120 seconds. So the protective system must be chosen taking care of the auto reclosure or reclosure time when some short or intermittent faults are occurring. So this is about the different types of protection schemes of transmission lines or feeders. Hope you have understood. Thank you.